Hi, and welcome to the ARC Digital Transformation Podcast. My name is Larry O'Brien. I'm Vice President of Research at ARC. Our subject today is cybersecurity, and I have with me Eric Cosman. Good afternoon, Eric.
Hi, good afternoon.
How you doing?
I'm doing fine. How are you?
Good. So you have kind of multiple hats. I know you're a colleague of mine at ARC. You do work with ARC, but you're also the president of ISA right now.
That's correct.
International Society for Automation, right?
Yes.
And you're also involved with the IEC 62443 ISA 99 committee.
That's correct. I co-chair that committee.
Can you tell us a little bit about your roles, sort of your multiple roles there before we get the discussion rolling?
Yeah, sure. I'm a retired chemical engineer. So I've been retired from my former employer now for 5 years. And since retiring, I've been sort of keeping my hand in the business, as it were, just because it's an area of ongoing interest for me. As far as cybersecurity is concerned, I've been working in the area of industrial cybersecurity actually since internally in my former company since about the late 1980s. Although we didn't call it cybersecurity, that wasn't the term we used back then. But I guess in a more concerted effort beginning in 2002. I helped write the chemical sector cybersecurity strategy for the American Chemistry Council. And at that was the same year we co-founded the ISA 99 committee that I co-chair. So you could say that I've been involved in industrial cybersecurity or cybersecurity for the critical infrastructure for pretty close to 20 years now.
Yeah, way before it was cool, right?
Yeah, exactly.
And that's what I want to talk about today, actually, is standards. And I know you've been in the world of standards for a long time. Standards is something that we talk a lot about at ARC. I think for most people, and I know you've said this before too, standards aren't written for the people that actually use them, right? Standards aren't written for civilians. I think a lot of people.
That's the phrase I use. The standards aren't read by civilians.
Yeah, and I steal that phrase all the time because it's so appropriate. And I've kind of been, on the periphery involved with standards committees, definitely not as deeply as you are. But and I think I feel kind of the same way you do, in that a lot of end users out there kind of find standards to be boring and confusing, and not a lot of understanding around standards, especially when it comes to cybersecurity, right? I think we've made progress with things like, the ISA 84 safety standard and IEC 61511 and so forth. But, other standards, maybe not so much. So tell me a little bit why you feel standards are kind of viewed the way they are right now, and how can we get people to embrace standards and really realize the importance of standards? Why are standards important in the first place?
Well, that's a really complicated question, and I'll try to keep it brief. But standards, fundamentally, the purpose of engineering standards is to codify and describe what is accepted engineering practice. So by definition, standards are lagging indicators. You standardize something after you understand it. And the purpose of a standard is to make sure that you get that written down so that people don't have to learn the same lessons that someone else did the hard way. Engineering and science-based industries, but engineering in particular, all forms of engineering, are based on standards. I mean, whether it's a simple standard for, drill bit sizes or Phillips screws, or whether it's a standard for cybersecurity. I mean, they're at the foundation of everything we do, and the reason for them is so that we don't have to keep relearning the same lessons. And then, of course, there's always the other reason is for interoperability. That's maybe a little less of a concern in the area of cybersecurity. It's more focused on not relearning the same lessons in a painful way. So, and I have said, as you mentioned, I've said, that standards can be arcane, maybe is a better word than boring, but people don't get excited about standards, and there's two aspects of that. One of them is what's in the standard, the content, and the other one is how the standard is actually created. And there are people that just thrive on standards creation. They just love the detail and the minutia and stuff like that. And, God bless them. I'm glad they exist. because that's how we get standards created. But then most people, have no patience for that kind of stuff. But standards, because it is an arcane process, because by definition, a standard has to be suitable, detailed enough to be able to specify against. And that takes time and attention. Now, the subject matter in the case of cybersecurity adds another layer. What's the right word? Not maybe a barrier, but an impediment to it, is that the subject matter itself is arcane and confusing to most people, and the details of security. And so, in a sense, in the cybersecurity standard, you're hit with a double whammy. You've got an arguably boring process talking about a subject matter that people don't understand. And I'm reminded of a quote or a phrase that a colleague of mine used to use, and it's sort of an imperfect parallel to this. He used to say, if you can remember the 60s, you weren't there. And you could apply that to cybersecurity standards. Like if you think you really understand the standards, you probably don't. So it's.
I agree with you there.
Yeah. So anyway, I rambled a little bit
evolve, there. Right? I mean, a good standard should evolve as technology evolves and the environment evolves and everything else. Good standards to me aren't fixed in stone, forever. No. They have to be able to adapt.
Particularly in the area of cybersecurity. I mean, as you know, the threat, vulnerability, and the consequence element of risk stays pretty constant, but the threat and vulnerability elements, they change all the time. So the standards have to evolve accordingly.
Can you give us kind of a broad brush description of, what is the 62443 cybersecurity standard,
sure.
And kind of what it covers?
Yep. Let me say, first of all, the logical place to start is when we formed the committee. Starts to sound like a biblical reference in the beginning. But when we formed the committee, we sat down and we said, we were charged by the ISA Standards and Practices Board to address the idea or address the challenge of securing industrial systems and identifying the implications for all of the existing ISA standards that were in existence at that time. So rather than trying to retroactively insert security into all of the standards in the portfolio, we chose what's been called the horizontal standard approach, where we would create a standard or set of standards that would apply cross-cut across those other ones. Okay, because security is not as much of a what, but a how, right? It applies to a lot of those other things. So we sat down and we started to mull this over. And the first thing we had to come up with was the definition of scope. Like any good engineering project, you better know what your scope is or you'll never be finished. And coincidentally or fortuitously, we defined our scope in terms of consequence. And if you look at the seminal standard in the series, which is 62443-1-1, it has a whole section where it explains that these standards are intended to be applied in cases where the following could occur. And that has served us extremely well because it does not limit us to any particular sector. So what we're really saying when we say industrial automation and control systems, which is the term that we use to describe what we're addressing, we're using that term very broadly. And our goal for the standard is to look at those systems across their entire life cycle, from conception, specification, selection, acquisition, configuration or integration, operation, support, and ultimately decommissioning. So where we started the committee with the idea that we'd have maybe one or two standards and a couple of technical reports, we now have like 14 documents in the series because we have to address all of those aspects of the life cycle. And that's kind of where we are today. So it's just to summarize, definition of industrial automation and control systems, very broad definition. We've applied it, and other people have applied it in a wide variety of sectors.
Yeah, which is, I think that's very good because that does allow you to apply it across a wide range of sectors
Yep.
And you and I have talked about some of the sectors out there that probably haven't applied 62443 yet, but probably very easily could.
Yep.
Like building automation and smart cities and so forth.
We've seen some. So if you think of it as a two-dimensional problem, scope of application, and then the entire life cycle being the other dimension. We feel that 62443 is the most comprehensive collection of standards in this subject area. But to your point about sectors, we've been very pleasantly surprised where people have come up to us with applications that we had never anticipated. And probably the first one that occurred was rail transportation. We weren't really thinking of rail transportation when we wrote the standards, but these standards have been applied in that space both in Europe and in North America. And there are other examples as well.
Yeah, I think the series of standards applies to really any OT, operational technology level system.
That's the beauty of what I said about defining our scope in terms of consequence. And it's consequence like, the compromise of the system could lead to the following, one or more of the following events. And you can imagine what those events would be, right? It's injury, loss of life, environmental upset, et cetera, et cetera.
So if I'm an end user today, and whether that's in manufacturing or infrastructure or energy or what have you, how does the 62443 standard relate to me? And you mentioned product selection. What are some of the things I have to keep in mind if I'm an end user who's buying products or specifying a project? How does that relate to my decisions and choices for suppliers and products and stuff like that?
Yeah, that's a good question. And I'll preface my comments by saying that I was an end user or worked for an asset owner for almost 40 years. So I know a little bit about that space and the challenges faced. Standards help the asset owner, in my opinion, by getting back to that point I made earlier about codifying accepted engineering practice. If you can find standards that adequately cover the landscape that you're talking about when you're contemplating buying or acquiring technology, and you match up the appropriate standards, you can save yourself a lot of grief and a lot of time and effort to, you don't have to become an expert in the subject. The purpose of the standard is to define what's considered minimally acceptable, and then you rely on the standard. And the best standards, if you take this definition of standards in a very broad sense, the best standards are the ones that have become so ubiquitous that they're almost invisible. If we think of things like consumer products, you can't even manufacture, much less have someone buy a consumer electronic product that is not UL certified or CSA certified if you're in Canada. And those certifications are based on standards. And so we need to get to the same place in security where people in the selection and acquisition process, they don't have to worry anymore whether the product that they're contemplating is securable. And I use that term very deliberately. They still have to worry about whether they're implementing it in a way that is secure. They can't duck that responsibility. But they don't have to worry anymore about the product as inherent insecurities. So that immediately takes that front end part of that comprehensive life cycle almost completely off the table. And then they can focus on integration, operation, and support. And whether they do that with by their own devices, with their own expertise, or with service providers and consultants, it doesn't matter, but they're starting with a solid base.
So how does 62443, how do I look for certified products that conform to 62443 for ISO 99?
Yeah, another good question. The IS, first of all, I assume, and well, maybe I shouldn't assume, but for the benefit of those listening to this podcast, when we say 62443, you can get those standards either as IEC standards, or which is the International Electrotechnical Commission based in Zurich, or you can get them as ISA standards, in which case they're ANSI ISA U.S. national standards. Regardless of which source you use for any given standard, the content is identical. It's developed by and large by the ISA 99 committee, and we do this in conjunction with IEC. Now, that preface in mind, ISA, the International Society of Automation, of which I have the honor of being president this year, has a component of its business called the ISA Security Compliance Institute. And that group, which is basically vendor and end user funded. So major asset owners like ExxonMobil and major suppliers like Honeywell and Rockwell and so forth fund that organization. And what that organization has done is to develop a set of conformance specifications for the standards. And they're called ISA Secure. And those specifications are freely available to anybody that wants to use them. And what the Compliance Institute is makes those available. A laboratory takes those specifications and puts together a testing regimen based on those specifications, and then offers as a service testing of either products or technology and components, or in some cases, the actual work process used to develop the products, and issues a certificate that basically says, we, a trusted third party, have examined this product, technology, or process, and we certify that it complies to the normative requirements of 62443. So that's how the process works.
Okay. So if I'm an end user, I can look for a product that has an ISA secure kind of stamp on it?
Yes.
So that could be a piece of hardware or software, or?
Yeah, it could be hardware, some combination of hardware or software, and then the other example is the actual development lifecycle, the process used to develop it, which is, think of it as kind of like an ISO 9000 certificate, but specifically for a software development process. That's
kind of where I was leading you, because the end users need to look at not just secure products,
right,
but the supplier uses secure development lifecycle when they created that product or that application,
and that they've got appropriate patch management processes, and that they get patch information and mitigation information out in a timely manner, and et cetera, et cetera, et cetera. Yeah. Now, the actual stamp
important things to talk about, because a lot of users aren't building this kind of criteria into their selection process, and I've always been surprised. And I actually, not that long ago, I was involved in projects where we sort of did the same thing. We were looking, assisting end users in selecting new distributed control systems. And it wasn't that long ago that we didn't have any cybersecurity criteria, attached to that selection process, which obviously we have now. But, it still surprises me how many end users out there and owner operators don't incorporate that into sort of their day-to-day product selection exercises, right?
Like I said, it's when I made the comment that the best certifications are the ones that are almost invisible. We haven't reached that point in security yet. We will get to that point eventually, where people don't even give it a second thought. There's a minimum performance level that just nobody would even, in their wildest dreams, consider going below. But we're getting there, but we're not quite there yet.
Yeah, but there are plenty of products out there that don't meet that minimal performance level, for sure. Well, especially now with IoT, right? With
exactly.
Yeah.
The challenge that we have in the information technology and communications industry writ large is that the emphasis and the onus is on responsiveness, innovation, and speed of delivery to the market. And so let me use a simple example. We all have a cell phone in our pocket. It's probably set up with some apps on it. So you've got a connection to an app store. Your apps are probably set up to auto update. Do you think that those apps are recertified between some of those updates that are only days apart? Probably not. That's not a model we can afford to follow in mission critical applications.
Yep, totally agree. It's not the consumer world, for sure.
And the difference is consequences, pure and simple. If your app on your phone doesn't work, it's not the end of the world. If an app controlling a hazardous process doesn't work, it was still not the end of the world, but it could be the beginning of a very bad day.
Yep, absolutely. its consequence, right?
Yeah.
Like you mentioned earlier. So today we have COVID-19. A lot of companies are really stretched thin in terms of budgets and everything like that. What kind of an impact do you think that's going to have on product certifications and, end users paying attention to certified products? Is that something that's going to fall by the wayside, or do we actually see that increasing now? As the end users try to avoid risk, or
yeah. That's really hard to give a general answer to. I think the practical answer, likelihood is that people have only so many hours in the day, and they're going to shift some of their emphasis from, security and some of this other stuff out of necessity because they have to focus on operational continuity issues related to the pandemic. But it is my hope that as they do that, they will get a broader perspective on what exactly operational continuity means and what those consequences really look like when they occur.
Mm-hmm.
Because an interruption to your business, be it from a pandemic or from a cyber attack, it's an interruption. And maybe they'll start thinking more seriously about some of the consequences. And when this pandemic passes, which it inevitably must, they'll have maybe a heightened awareness about being better prepared. And I see a natural convergence of continuity planning for occurrences ranging from catastrophic weather events to pandemics to cyber attacks, because or equipment failures, massive equipment failures. It's so much of the fundamentals are the same. It's be prepared.
Yeah, and some of them are related, right? I mean, you don't want to leave yourself open to a cyber attack because of COVID-19, because, you set 90% of your workforce home, to work from home. Or, even people that work in OT environments that need access to very sensitive and mission critical data at the OT level, right? So what I see happening right now is there's a lot more exposure. The wave of remote workers is creating a bigger concern around cybersecurity than we've seen before. A lot of these things are going to become permanent trends, right? It's not just going to be a reaction to COVID-19, but these things will stick. Even after COVID-19 goes away, end users are going to be like, well, this remote monitoring thing is actually working out pretty well. Maybe we don't need all these people on site all the time. So how can we really implement, some really secure remote monitoring and operations and maybe expand this program? And so I see more investment in cybersecurity in many ways as a result of COVID-19. And
I would agree. And that scenario that you just painted with words, it's our challenge in those of us that are pursuing this and promoting security to make sure that the latter part of that sentence is not overlooked. So yes, people will say, wow, look, all things we can do remotely, and, maybe we should do them even after the pandemic ends, and so on and so on. And by the way, we need to do it securely, because if they just, open the gates and let everybody do everything remotely without considering security, that's not going to end well. And whether it's before or after the pandemic passes, it's still not going to end well. So I think it's incumbent upon us in this space to help people be productive and efficient and secure at the same time.
Yeah, and I think a lot of the threat actors see this current environment as a big opportunity. A lot of these opportunistic attacks that we've seen, a lot of ransomware kind of stuff, but also stuff that's targeted right at the OT level, at OT level systems.
Incidentally, I was recently involved in a study that was conducted by a major media company, and they interviewed several hundred executive level people in major Fortune 500 companies about security and awareness, and particularly for the critical infrastructure now. And the good news, based on the results of that survey, is people's attention was already on this, And the pandemic has in many ways only sharpened that. So that's good news.
Yeah, I think so too. It's also accelerated things like digital transformation programs. I think the adoption of IoT technologies, cloud computing, all of which carries a security risk as well.
Well, when you think about all this technology and look at it from a perspective of someone who's not a technologist, and, we've all heard the jokes about executives, they don't know anything about technology. And in some cases, that can't be further from the truth. But if people are not enamored with technology, but they see the value of it, what they want is assurances from the people who are experts in the technology that by availing themselves of the value, they're not putting themselves at risk, whether it's cybersecurity risk or the risk of flawed or flaky products or companies that pop up overnight and then disappear without a trace. They want assurances. And in the security space, that's what we're here to do with a combination of expertise, experience, and that experience reflected in those codified standards.
So standards are a way of managing risk.
Absolutely.
Yeah.
It's, why, again, going back to the fundamentals, why should you have to learn the same sad lesson over and over again?
Mm-hmm. Yeah, exactly. So what's the difference between IEC 62443/ISA 99? I'm not sure exactly how, I should refer to that every time, but I always mention both of them at the same time. But like you said, ISA 99 is the North American Standards Organization, right? ISA and ANSI, and IEC is the International Electrotechnical Commission. So
yeah, okay.
So say 62443 to keep it simple.
Let me keep it very simple. First of all, let's talk about the numbers: 99 and 62443. When the standards were originally created, the first few that were created, they were called ISA 99 standards. The reason for the 99 is simply that it was the 99th standard subject that ISA took up.
Name of the committee, yeah.
No more significant than that. And the committee was named ISA 99. Shortly after we got going, we formed a strong working bonded relationship with IEC. IEC has a different nomenclature for their standards, and they use 5-digit numbers. And they had contemplated embarking on an effort to develop a cybersecurity standard, and the number they assigned to it was 62443. So what we decided was, rather naively, as it turns out, we thought, well, maybe we can avoid confusing people too much by saying, and this is where we stand today, and this is a summary that you can sort of take away from this. 62443 is the standard. 99 is the committee.
Okay.
The standard 62443 can be obtained either from IEC or from ISA, but it doesn't matter because the content's the same.
And it is an international standard. I mean, this is the international standard of reference for cybersecurity for all the manufacturing industries, in my mind. But let's talk about critical infrastructure for a minute, because critical infrastructure to me goes beyond some of the industries that I would include in manufacturing, that we do include in manufacturing at ARC. You have like water, wastewater, power transmission and distribution, which we consider to be critical infrastructure. But you also have other industries that might not be part of the traditional industrial umbrella. Stuff that might be related to defense or building automation or smart city type applications where it's not the same level of it's not a refinery that's going to blow up, but maybe it's a stormwater management system that's not going to function properly, or a water distribution network that might fail, or like we saw in power transmission and distribution, where in the Ukraine, right, where the Advanced Persistent Threat Group shut down a distribution station, shut down power in the Ukraine to many, I don't remember exactly how many people, but I know it was in the middle of winter time, and these are all threats to human health and safety and life, basically. So How far along is the infrastructure sector really in embracing these kind of standards? I mean, when you look industry to industry and sector by sector, there's a lot of variance as far as how much they embrace standards, how much they understand the world of standards, all the way to some applications where they seemingly don't even think about cybersecurity. Like you rarely hear it mentioned.
Well, let's go back to the fundamentals and look at that term, critical infrastructure. Critical infrastructure, the generic definition of that term includes systems and their components, of which for which the compromise or destruction or failure to operate would have adverse consequences at a societal level. Now, each country in the world has their own specific definition of what they consider their critical infrastructure. They're very similar, but they're not identical. In the United States, the Department of Homeland Security and the federal government has defined critical infrastructure as consisting of, I can never remember the exact number, it's either 16 or 18 specific sectors. And what they share is a significant negative event in any of those sectors would have consequences at a societal level. Mm-hmm. Okay, so that's the first thing to understand. Now, to your point about some sectors not worrying about cybersecurity, I'll use my favorite example. One of the critical infrastructure sectors in the United States is national monuments.
Okay.
It's included because it's in the judgment of the people that put this together that if someone were to blow up Mount Rushmore, that would have societal level consequences. They're not cyber consequences.
I would agree with you there, yeah.
But they shake the public confidence.
Yeah.
So it's reasonable to assume that national monuments probably doesn't put cybersecurity too much at the top of their list. At the other extreme, another critical infrastructure sector is energy. Well, negative societal level consequences there is essentially loss of energy. And since the energy system operates with computers and networks, cybersecurity is extremely high on their list. And all the others fall somewhere in between. So that's probably the simplest way to understand it, is that does cybersecurity have to be front and center for every critical infrastructure sector? No. Is it more than, is it the majority? Yes. But every sector has to address the risk, which again is a combination of threat, vulnerability, and consequence, in their own way. Some sectors have done this by defining their own standards. So the bulk electrical system has NERC-CIP. Mm-hmm. And those they have their own standards, and they seem to be working quite well for them. Others, like the chemical sector, which is where I used to work, made a deliberate choice and said, we are not going to develop chemical sector specific standards. We are going to throw our resources behind industry-wide non-sector specific standards, which is how I came to be a founding member of ISA 99. Does that help?
Yeah, that helps, I think. And none of these are really enforced by the government, right? Because I get this question all the time about cybersecurity regulations, and there just aren't that many cybersecurity regulations out there. We have state level efforts like the California IoT law that went into effect, which really is targeted at consumer products, right, for Internet of Things, like smart home kind of things and personal assistants and things like that. I think Washington has a similar law. At the federal level, there really doesn't seem to be much happening. What do you think the regulatory environment's going to look like in the future? And how are standards going to ease that process? Are we going to be seeing more regulations, and who's going to be enforcing those regulations? Is it going to be the government, or is it going to be insurance companies or banks?
Probably all of the above.
Yeah,
I think you mentioned banks, and I forgot about banks, but that finance is clearly a part of the critical infrastructure, and finance has very strict regulations that they develop within their own sector about cybersecurity. private sector, most of the critical, you probably heard most of the critical infrastructure sector in the United States is in private hands. It's not government owned. So a private sector organization, and I'll use the American Chemistry Council for the chemical industry, puts together I guess you'd call it a self-generated regulation. In the case of the chemical industry, it's the responsible care. It's called responsible care. And responsible care has a security code. And basically, to be a member in good standing in the American Chemistry Council and pass muster as a member of the chemical industry, you have to adhere to that code. Mm-hmm. And it has a cyber component. On the other hand, if you go to the energy sector, NERC defined the CIP standards, the critical infrastructure protection standards, but FERC, and I don't even remember what FERC stands for, Federal Electrical something. It's a regulatory agency. They are the one, that's a federal government agency, and they require that you follow CIP, NERC CIP.
Yeah, so they are the teeth behind NERC CIP. They
yes.
enforce that NERC CIP is being followed, yeah.
So every critical infrastructure sector has a corresponding federal agency. Okay, so for the chemical sector, it's the Department of Homeland Security, and they have the what they call a critical CFATS standards.
Yes.
I can't remember. Yeah, and CFATS has a cybersecurity component. So if you just go down the list of critical infrastructure sectors, there's a corresponding federal agency. So for medical devices, for example, or healthcare, health and human services, or healthcare in general, it's basically the FDA. And our agencies, government agencies coming forward with regulations, you betcha. And, again, we know what the politics is, what politics is like, and it doesn't matter what country, depending on your political stripe. One side of the political spectrum will allow the private sector to try to do it on their own, and the other one will leap immediately to regulation. It really depends on whether you lean to the left or the right.
Yep. I think we're all familiar with that scenario.
And right now in the U.S., we're in a more, small c conservative, more right-wing political climate, which says let the industry regulate itself.
Yep, we're letting the industry or many industries police themselves.
Yeah.
But 62443 to me is if you're going to police yourself and you're in industry and critical infrastructure, that's the standard that you want to follow. I don't know of any other standards. There's NIST, the NIST framework, and a lot of people mention ISA and NIST and some of these other efforts in the same breath, but they're all really kind of different, right? What do you see as some of the other initiatives that are maybe complementary to ISA or IEC 62443, and maybe some that are competing standards? Well,
since you mentioned NIST, let me talk about that for just a moment, and I'll try to keep this brief. National Institute of Standards and Technology, which is a division of the Department of Commerce, national lab based in, or its main labs are in Gaithersburg, Maryland. They have these what they call special publications, SP followed by some numbers. The two that are most germane to this subject are SP 800-53 and SP 800-82. The first one is general IT security standards, and the second one is an addendum to that for industrial control systems. The content of those two special publications is not radically different than what you would find in any private sector cybersecurity guidance, including the standards, the 62443 standards. Okay. So if you were to take SP 882 and compare it to what's in 62443, there wouldn't be a radical amount of difference, and they don't fundamentally disagree. The special publications of NIST are intended primarily to provide guidance and direction for federal government agencies. They don't have that teeth for the private sector. Many private sector people look to them for guidance, and that's wonderful. The good news is if you follow SP 882 and 53, it looks at the problem differently, but it covers much the same territory as 62443. 62443 gets into a little bit broader spectrum in terms of the life cycle, and it's international. So in some parts of the world, people don't look to NIST simply because it's a U.S. government agency. And so an international standard is not country specific. The good news is that we have very strong relationships with NIST. We have people in NIST contributing to 62443 in a very meaningful way, co-chairing our work groups and so forth. And so we're making sure that they don't diverge. And then the last thing I'll say about NIST that everybody likes to talk about is the NIST framework. And the framework is not a standard. It's called NIST Cybersecurity Framework, or CSF for short. It is I would call it a methodology, a way to structure your cybersecurity response. And in the core of the framework, it has a set of references to external and internal NIST sources where you can go get the details of what you should be doing in this particular step in the methodology and where to get your guidance. And those reference documents include 62443. So the framework is complementary to standards. It's not an alternative.
Yeah, thanks for pointing that out. I thought it was worth getting into that in a little more detail.
You're starting to get into, the old saying, right? Anybody that likes sausage doesn't want to see how it's made.
Yeah, you don't want to see how it's made. Yeah. I think the important point is they're complementary, right? It's not I got to pick the NIST framework, or I have to pick 62443, or these are really all complementary efforts, and like you said, they don't fundamentally disagree on anything.
If you go back to the genesis of this effort back in the early part of the 21st century, that sounds weird to say that, but circa 2002, someone opined at that point, and I never challenged them on it, but it wasn't a hair-raising opinion. They said the number of people in the world at that time that fully understood the challenges of industrial cybersecurity was in the double digits. It was less than 100 people. Now, 20 years later, it's considerably more than that. But the good news is that community is well formed. From those roots, it's well formed. And most of the true experts, and I don't count myself as one of them, by the way, they know each other. What does that mean? Is that it means if you go to somebody who's working, whether they're working in NIST, whether they're working in 62443, whether they're working in IEC, they know each other. And you're not going to get a lot of what I would call fundamental disagreement. Industrial cybersecurity has emerged as an engineering discipline. And that's what we need. Yeah,
that is what we need. How about resources? For our listeners out there, can you point out any good resources that they can go to? ISA.org, I'm sure, but
you can go to isa.org/ISA99, which will get you not a whole lot because all it does is introduce you to the committee. Let me talk about the ISA ones first, real quickly. So there's isa.org/ISA99. That's a committee landing page. We're going to be building out from that over time, but right now it'll introduce you to the committee. If you're interested in the ISA Secure compliance specifications, you can go just do a web search of ISA Secure, all one word, or you can go, I think it's isasecure.org, and find out about compliance and compliance specifications. You can also go to the IEC website and look up 62443 and find out what they have to say about the standards. So that's all, 62443 standards and related compliance sources. If nothing else works, you can send an email to isachair@gmail.com, and that will come to me and my co-chair in the committee if you're interested in learning more about the committee and what we're doing and what we're working on and maybe even getting involved. And then, so those are all ISA sources, and we're looking for all kinds of other opportunities for outreach. I would be remiss if I didn't mention the NIST that I already talked about, the NIST Cybersecurity Framework. If you just do a web search on NIST Cybersecurity Framework, it'll take you to an extensive set of web pages that NIST maintains about the framework and how it's applied and what it does and what it doesn't do and how it relates to standards and all the rest of that. So the subject is not hard to find. If you search, pick a couple of keywords like 62443 and NIST cybersecurity framework, very quickly you'll have more than enough to get started.
And if we go to ISA Secure, then we can find a list of products that have been tested and certified.
Yes.
And this includes systems and instruments and products and all that stuff?
Yeah. Well, ISA Secure has some of them. Unfortunately, don't have a complete list because whoever's doing, depending on who does the certification. So TUV is a big certification company. Okay. TUV maintains a complete list of everything they've certified. But it's interesting that you mentioned that because I was in a conversation just the other day where somebody pointed out that there needs to be an aggregation of all of those, regardless of who did the certification. And I believe that that's something that there's an organization I did not mention, which is called the ISA Global Cybersecurity Alliance. And that group is taking on that task, is seriously contemplating taking on that task.
Yeah, I know the world of certifications can be pretty arcane, and I went through that when I covered the world of process safety. So, there's different TUV organizations, and there's Exida and other companies that do certs, and trying to sort of decode what the certs mean and how they were tested, and that can be kind of confusing. I know.
I guess the last thing I'd say on that subject is, since we are talking here in the context of an ARC podcast, call us at ARC.
Yeah,
reach out to us. Larry, me, Sid. This podcast will show up on the ARC website along with links and email links, and we'd be happy to anyone out there listening to point you in the right direction. Good.
Yeah. Thanks. I think I try a little too hard not to be self-promotional on ARC when we do these podcasts, but we certainly have a lot of experience in this regard and can definitely help you there.
In my case, it's like, pick your poison. You can contact me as ISA president. You can contact me as ISA 99 co-chair. You can contact me as a consultant to ARC. It's all going to come to me anyway.
Right. So. You're a busy man. I know. So I think to sum up, standards are important. They're a good way to manage risk. Yep. Embracing standards for cybersecurity is very important right now, even more so in this age of COVID-19 and the rush to the remote workforce and everything else. We're creating all kinds of, additional cybersecurity risks, threat groups are ramping up their activity. Try and build cybersecurity into your product selection and specification process. Talk to your vendors about what they're doing and what kind of certifications they have. And not just for cybersecurity products, but for all products, right? Whether it's a control system or HMI or whatever. Cybersecurity has to be part of the equation. And what else am I missing? What else do we need to hammer home at the end?
You've covered it pretty well. I mean, I wrote a paper for ARC several months back where I compared the stages of cybersecurity awareness to the stages of grief. And this first stage of grief is denial. So my best advice to anybody out there looking at this is get past the denial stage. And you can benefit from standards without becoming experts in standards. Knowing that they're there, find an advisor who you trust that knows presumably more than you do and can help you navigate your way through the sometimes confusing forest. And the benefits are there.
Totally agree. Well, thanks for joining us today, Eric. This has been the ARC Digital Transformation Podcast. We were talking today with Eric Cosman of both ISA and ARC about cybersecurity standards, and then specifically the IEC 62443 cybersecurity standard. And we look forward to seeing you next time. Bye-bye.
Thanks.